purpose of this video is going to be to use the definition of the derivative that we've been working with all through this section to first find the derivatives of some important families of functions. So not just do one, but do entire families of functions at once. And then also use the definition of the derivative to show that some functions actually don't have derivatives at particular points. So once again, here is our definition of the derivative. The first family that we're going to be talking about is going to be, let's talk about constant functions. So suppose that f of x equals b, so we're working with a constant function here. And let's apply that, the definition. So f prime of a, so here b is a constant. F prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h. Now, the function is a constant, and so f of a plus h and f of a, they're both the same thing. They are both equal to b. And so we end up with the limit as h goes to 0 of b minus b over h, which is the limit as h goes to 0 of 0 over h. And this limit is 0. So note that this isn't a case where we have h over h, and that's a 0 over 0 indeterminate form that we have to use some more manipulations to. This is a case where the numerator is literally equal to 0. And so at this point we are done. The derivative here is 0 no matter what a is. That's not too bad to see, to think about slope of the tangent line. If we have a constant function, well, take a look. The slope of the tangent line should just be the line itself, and that has slope 0. So this makes sense. Let's also do the next most complicated family of functions we can think of. Let's do g of x is equal to mx plus b. So here m and b are constant, so this is a generic looking linear function. So once again, f prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h. And so now applying the limit definition, or sorry, plugging in here, we have f of a plus h, so that's everywhere we see an x, we're going to plop in a plus h. So m times x plus b minus m times x plus b. Everywhere we see an x, we're replacing that with an a. Okay, we simplify the numerator. What's going on here? We have ma plus mh plus b minus ma minus b. All of that over h, and what cancels here? B's cancel, MA's cancel, and so we're just left with the limit as h goes to 0 of mh over h. Those h's cancel. And so this is the limit as h goes to 0 of m. M is a constant. You know, through all of this we should be thinking of, 3x plus 1 or something like that. And there's a constant, so the derivative here is just m. And so once again, this matches what we think of for here is our g of x. Oops, what's the mistake I made here? Way back there. G prime of a is what we were doing. And so this line has slope m, and accordingly the slope of the tangent line is m. And so that checks out with what we think should be going on here. Okay, let me wrap up this video here a little bit early. I'll save the examples for functions that aren't differentiable for the next video.